Chemical reaction is a process in which a substance or substances is changed into one or more new substances. A chemical equation is a short scientific representation of a chemical reaction by using symbols or formula of the substances involved in the reaction. Here are the fundamental aspects of any chemical equation. Number 1, the substances undergoing reaction are called reactants, and their formulas are placed on the left side of the equation. Number 2, the substances generated by the reaction are called products, and their formulas are placed on the right side of the equation. Number 3, plus signs separate individual reactant and product formulas, and an arrow separates the reactant and product, left and right sides of the equation. The relative numbers of reactant and product species are represented by coefficients, numbers placed immediately to the left of its formula. A coefficient of 1 is typically omitted. So let's discuss the different types of chemical reaction. Number 1 is combination reaction. In a combination reaction, 2 or more substances combine to form one or more products. The general equation is A plus B, then it will produce product AB. An example of the equation is the reaction between sodium and chlorine to produce sodium chloride. So you can see here that two elements are combined to form a single product. The second one is decomposition reaction. It is a reaction in which a single compound is broken into 2 or more smaller compounds or elements. So we have a single reactant, AB, then we apply heat or allow electric current to pass through the solution, then you will produce product A and product B. An example is the decomposition of barium bicarbonate. Then it will produce barium oxide, water, and carbon dioxide. The third one is single replacement reaction. In a single replacement reaction, a free element replaces another element in a compound. The general formula is A plus BC, then the product will be AC plus B. In this type of chemical reaction, element A will try to displace element B on the reaction. Element A must be more active than element B for it to substitute that element in a compound. So how will you know whether element A is more active than element B or not? We will refer to the activity series of metals and non-metals. So what is activity series? It is a list of common metals in decreasing order of their ability to replace metal ions in a compound. If we are using activity series for metals, but if we are using activity series for non-metals, we will check whether the non-metallic element is more active than another non-metallic element. So here is table 2. The most active metal is lithium, followed by potassium, barium, strontium, and so forth and so on. So the least active metal is gold, since it is located on the last part. For the activity series of non-metal, you can see that the most active non-metal is fluorine, followed by chlorine, bromine, and the last one is iodine. So let's have an example of single replacement reaction. Magnesium plus aluminum oxide. If we will refer to the activity series, you will notice that magnesium comes before aluminum. So it means that magnesium can replace aluminum in this chemical equation. So magnesium combines with oxygen, forming magnesium oxide, And then we will have aluminum as product B. The last type of chemical reaction is double replacement reaction. It is a reaction in which two compounds exchange metallic and non-metallic portions to form two new compounds. So we have product A plus product B. A will combine with D, and then C will combine with B. A here combines with D. Since A is a cation, it will combine with anion D. Now, C here is cation, so it will come first, followed by B, which is anion. So in a compound, the first element is always positive, then it will be followed with a negative element or anion. An example, potassium bromide plus calcium oxide, then it will produce potassium oxide and calcium bromide. So let's check if you understand what we have discussed earlier. Identify the types of chemical reaction. Okay, so let's check if your answers are correct. Number 1 is the reaction or the decomposition of sodium chlorate. Then it will produce sodium oxide and oxygen. So the answer for number 1 is decomposition reaction. Number 2, we have calcium and fluorine. Then it will produce calcium fluoride. And that is combination reaction. The third one is barium oxide plus lithium chloride. Then it will produce barium fluoride plus lithium oxide. That type of reaction is double replacement reaction, since we have a compound and another compound. Number 4, potassium plus aluminum oxide. Then it will produce potassium oxide plus aluminum. And the type of reaction is single replacement reaction. Did you get it right? Very good. So let's continue. We need to balance every chemical equation in order to follow the law of conservation of mass. The law of conservation of mass states mass is neither created nor destroyed in a chemical reactions. In other words, the mass of any one element at the beginning of the reaction will equal to the mass of that element at the end of the reaction. If we account for all reactants and products in a chemical reaction, the total mass will be the same at any point in any closed system. So let's have an example. The reaction between barium and oxygen forming barium oxide. So we will balance this by inspection. We will have on the left side reactant and then on the right side product. So the element present are barium, oxygen on the reactant, and on the product we have barium and oxygen also. After that, we will determine the number of atoms by simply looking at the subscript number. Since you don't see a number below barium atom, it means 1. And then for oxygen, we have 2. Since you see number 2 here, and then barium, 1. Oxygen, no number also, so 1. Now, let us analyze if the equation is already balanced. We have same number of barium before and after the reaction, 1. Oxygen, 2 for the reactant, and then 1 for the product. So, it means that the equation is not yet balanced. So, since we are lacking on the product side, we will place coefficient 2 on barium oxide part. Now, when you place 2 here, automatically all of the elements here will be multiplied by 2. So, for barium, that is 1 times 2, the answer is 2. And then oxygen, 1 times 2, still the answer is 2. So, it's okay now. We have a balanced oxygen atoms. But how about barium? For the product, we have 2 atoms, and for the reactant, 1 atom only. So it means that we will place a coefficient here. Always start with number 2. Now when you place 2 here, you will multiply this barium atom by 2, and you can see that the equation is already balanced. Barium, 2 atoms on the reactants, and on the product side, 2 atoms also. Oxygen, 2 atoms on the reactant, and 2 atoms on the product side. So that is how you balance the chemical equation by inspection. Let's have another example. Lithium carbonate, then it will produce lithium oxide plus carbon dioxide. Whenever we decompose a metallic carbonate, the product will always be metallic oxide plus carbon dioxide. So still we will have left side reactant, right side product. We will break down the elements. So we have lithium for the reactant, carbon, and oxygen. On the product side, we have lithium, oxygen, carbon, and another oxygen. After that, we will refer to the subscript number. So you see number 2 here for lithium. That's why it has initially 2 atoms. Carbon, no number, so it means 1. Oxygen, 3. On the product side, we have 2 here for lithium, so 2 atoms. Oxygen, no number, so it means 1. Carbon, 1. Oxygen, 2. Now let's analyze if the equation is already balanced. We have 2 lithium atom on the reactant, on the product 2 also. So balance. Carbon 1 on the reactant, on the other side 1 also. Oxygen 3, and then here we see a plus sign, so it means that we can add all the oxygen atoms here. So 2 plus 1, 3. The equation is already balanced. Okay, so let's continue. Let's have another example. This time we have a double replacement reaction. We can see a cation combined with polyatomic ion. So let's list down the element, the cation and polyatomic ion. So we have magnesium, then chlorate, potassium, and phosphate. On the other side, we have magnesium, phosphate, potassium, and chlorate. We will consider the polyatomic ion as 1 so that it will be easier for you to balance the chemical equation. So since we don't see a subscript for magnesium, it means 1. Chlorine, it is enclosed in parentheses. If you don't see a number here, it means 1. And then you will multiply it with the subscript outside. So that is 1 times 2, 2 atoms for chlorate, for chlorine. Okay? So in this equation, okay, so here we have an example of a double replacement reaction. The reaction between magnesium chlorate and potassium phosphate to produce magnesium phosphate and potassium chlorate. So again, we will balance this by inspection. So let's break down the elements. In this example, we will consider the polyatomic ion as 1 so that you can balance the equation in an easier manner. So instead of considering chlorine and oxygen as separate elements, we will consider it as polyatomic ion, and that is chlorate. So let's list down the elements present, element and polyatomic ion present in this compound. The elements are magnesium, then polyatomic chlorate, potassium, and phosphate. On the product side, magnesium, chlorate, potassium, and phosphate. After that, let's determine the number of atoms. Since you don't see a number below magnesium, it means 1. And then chlorate here is enclosed in a parenthesis, so it means 2 atoms. Potassium, 3. Phosphate, no parenthesis, so it means 1. Magnesium, 3. And then phosphate, 2. since it is enclosed in a parenthesis. No number for potassium, so it means 1. Chlorate, no parenthesis, so 1 also. Now, let's compare the element, the cation and polyatomic ion. So, for magnesium, 1 only on the reactant side, and on the product side, 3. So, it means that we need to place a coefficient on product A. So, we will have 3. Now, when you place 3 here as a coefficient, automatically, you will multiply magnesium and chlorate by 3. So, we have a balanced magnesium atom, 3. And for chlorate, 2 times 3 is 6. On the other side, 1 only. So, to balance the equation, we will place a number here, and that number is 6. When you place 6 here, automatically, you need to multiply chlorate with 6, and then potassium with 6 also. So, you have a balanced chlorate, polyatomic ion, both 6. But what happened to the potassium atom? Initially, we have 3, and now we have 6 on the product. So, it means that we need to adjust this reactant side, reactant B. So, we will place a number here, coefficient 2. And when you place coefficient 2 on that part, it means that you will multiply potassium and phosphate with 2, since it is considered as a compound here. So, 3 times 2 is 6 for potassium, balance already. And for phosphate, 2 to a phosphate polyatomic ion. So, the equation is already balanced. Thank you for watching.